Hello everyone, this is Fahad Mirza and I welcome you to the channel. In this video, we are going to have a look at newly released Eagle family of models from NVIDIA. This model is a vision language model, which means that it can deal with images and videos and it can describe them. You can also do VQA or visual question answering. Before I show you the installation and we play around with different images and videos, let's have a quick look at bit of an architecture of this model in very simple words. So this is a series of open source vision language models that aim to narrow the gap with proprietary models. It focuses on post-training VLMs from a data-centric perspective and emphasizes transparent data strategies, robust training recipes, and model design. They have also shared some of the training details on the model card, and I will drop the link to it in video's description. But the thing which really interests me is that all the three models from this family, they use SIGLIP. SIGLIP is an image embedding model that builds upon CLIP framework but with a key modification, and that key modification is what makes this model separate from others. That modification is that it uses a sigmoid loss function instead of the traditional contrastive loss, because CLIP normally uses contrastive loss, but this embedding model which builds upon CLIP doesn't use that. So this change enables SIGLIP to achieve significant improvement in zero shot detection tasks, which is a notable advancement in the field of vision language models in my opinion. Now, this Eagle-2 family comes in 1 billion, 2 billion and 9 billion flavor. Both 1 billion and 2 billion use SIGLIP, whereas 9 billion uses SIGLIP plus Connext for vision, which is a standard. So of course the performance and the quality of 9 billion would be better than the 1 billion and 2 billion, but just because most of the people have lower VRAM, so that is why I have decided to show you how it performs in the 1 billion. If you want to use 2 billion or 9 billion, everything remains the same except the model name. So that is a quick intro. Let's try to get it installed. For that, let me give a huge shout out to Massed Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. This is my Ubuntu system, and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. Let's quickly create a virtual environment. And now let me create all the prerequisites, so which include torch, transformers and all that stuff. This is going to take 2 to 3 minutes. While that happens, let me also introduce you to the sponsors of the video, who are iGentBot. iGentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in video's description. So let's go back and check what is happening. It is going to take a couple of minutes more. Everything is installed, and now let me show you the inference code which thankfully NVIDIA has shared. In my opinion, they could have made this code quite easy, but I think it is unnecessarily complicated, but that is fine. Let me explain in simple words what is happening in this code. So we are importing the libraries which we have installed, and then this code is for a model worker that executes a VLM or vision language model, which is Eagle-2 of course. The model worker here, let me scroll down. It has been designed to process input prompts that may include images or videos and generate text responses. It loads a pre-trained Eagle-2 series model and tokenizer, and then these are few of the functions which are getting the frames from video. This basically converts our video prompt into the model compatible prompt. This loads the video, this loads the image, and then it transforms our input, and you can see that it is using SIGLIP here. And from there, after transposing it, it is doing the aspect ratio for the video height and width and stuff. and then it is pre-processing. This is all NVIDIA stuff, where it is just resizing the image, making it compatible to the model. You don't have to worry about it. And then it is splitting the model to get loaded in embedding and all that stuff. And this is where it is defining that model worker. So after loading the model and tokenizer, it defines several functions for loading and processing images and videos, including extracting frames from videos and applying transformations to the images. And then this is where it is defining a model worker class that encapsulates the model and its associated functions, which we just saw. The model worker class also has a generate method that takes a prompt and generates a text response using the model. And then you can see that this is just checking, reloading the model and all that stuff. This is where it is generating with all the hyperparameters using also pillow. So this is what I was referring to. We have covered heaps of vision models, and they really don't let us worry about all these stuffs, but it seems this model shows what is happening, maybe more flexible. Anyway, so if you want to use Eagle 2 billion, you just need to change 1 billion to 2 billion here, or 9 billion in both of these paths. Okay, so this is where it is giving us a prompt, and it is giving us that describe this image in detail, and then this is the URL of the image which it accesses. We will also be using the local image. Let me quickly show you this image, and then I will run this code. And this is the image, and of course it's NVIDIA's logo. Anyway, so let me go to my local system, and then I'm just going to quickly clear my screen, and then I'm going to run that code which I just showed you. And as soon as I have run it, it is asking me to install peft here, which is not present in their directory, which is fine. We can quickly do it, shouldn't take too long. And peft is installed, which is parameter efficient fine tuning. Let me rerun it. And if you remember, it also downloaded the model first time when we ran it. So let me run it again. And now the model is being downloaded. It is just over 2 gig of size, which is quite good. And then as soon as we run it, it just shows us this GUI, which is quite cool. It will open in your browser, and then you can start with your images or with your videos. So it has just described this image. Now you can browse more files. For instance, I can select this image of my cathedral here, for example, this one, and I'm going to ask it what is the location in this image. The model seems a bit clunky to me, but the good thing is that it sort of does the reasoning, and it has failed it. It couldn't identify the location in this one. Okay, so now let me select a video, or maybe we'll do the OCR first and then we will check out the video. So I have given it this image to take out extract the text, and I can see it is pretty average. I would say a lot of the umlaut and special characters have been missed from this. So not, maybe I can expand it a bit. This is the one. This is the image which I am doing the OCR with. As you can see, there are a lot of umlauts and stuff. And now let's try out the video. So for video, I'm just checking this one. This is just an AI generated video of a cat on the top of the hill and stuff. So if I upload this video which I just did in this GUI, you see that it has converted it into the frame, and then I'm asking it to describe the video, and it is okay. Temp cat, so it couldn't find it. Let me do it again. I'll just refresh the page. So refreshing the page has done the trick, and it says the video appears to be a series of animal theme vignettes, each showcasing different animals in unique and engaging ways, which is totally wrong. So a very average model, I would say. Quite disappointing, to be honest, especially this 1 billion one. And we have seen many models in vision and of course in video too, which are quite efficient, especially the images model. around 1 billion mark, even less, have performed quite well from various other providers. So for me, I don't think so this is a model at the moment which is ready. Maybe in the next version. Let me know your thoughts. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.